So now here the first problem is given a sphere of mass m and radius r slips on a rough horizontal plane. At some instant it has a linear velocity and a rotational velocity about the center. Omega naught is equal to v naught by 2r. So omega naught is equal to v naught by 2r. Now it is given omega naught is equal to v naught by 2r and it has the movement like this, and here you are given this is the velocity, that velocity is v naught and friction will be here like this. Friction will be here. Even though the direction of the friction is not mentioned, you can understand the direction of the friction should be like this only. Why? Because here in this case it is not the pure rolling at all. It is not pure rolling at all. A sphere of mass m and radius r slips on a rough horizontal plane. At some instant it has a linear velocity v naught and rotational velocity about the center is omega naught is equal to v naught by 2r. Rotational velocity about that center is v naught by 2r. That's meaning is given v naught is equal to 2r omega naught. That is v naught greater than r omega naught. V naught greater than r omega naught. Hence it is forward slipping. Hence it comes under the forward slipping. Its meaning is the contact points rub the road in a forward direction. That's why opposite that of the applied force, friction should be in opposite direction like this. That's why in this problem, even though the direction of the friction is not mentioned to you, you can understand the direction of the friction should be like this only, because it is nothing but it is coming under that forward slipping case. Because it is the omega naught is equal to v naught by 2r, v naught is equal to r omega naught, which is greater than that of the r omega naught. So now it is a forward slipping. Now here gradually it is coming into the pure rolling. So now you have to find out at the time of pure rolling, find the linear velocity of the sphere starts. Find the linear velocity after the sphere starts pure rolling. At the instant while it is getting that pure rolling, we have to find out that linear velocity, and that is v is equal to 6 by 7 v naught is given, that you have to find it now. So what are the equations that are coming here? So first v naught is equal to 2r omega naught and v naught greater than r omega naught. Here at the time of pure rolling, v is equal to r omega. V naught is equal to r omega, that should be. V naught is equal to. So here v is equal to, that is the velocity of the center of mass is equal to r omega, and for that you have to find out that velocity v is equal to u plus at to be taken. So here v is equal to u plus at, that is to be taken, and here u is equal to u, that can be taken as the v naught. So it is v naught is equal to 2r omega naught. So that's why v naught is here. Here that linear velocity gradually decrease. Here that linear velocity gradually decrease. So gradually decrease, suppose we think so after time t seconds that linear velocity is gradually decreasing to some velocity v is here, and in that case that velocity v, where it is v naught plus at. A means that is the retardation given by this frictional force. The retardation given by this frictional force, you have to find out that retardation. That retardation is nothing but A is equal to Fk by m. It is nothing but mu k mg by m. So it is the mu kg. So it is retardation given by that frictional force, and because of the retardation it is mu kg is here, and it happens after t seconds. So that's why it is t is taken. Now it is becoming v naught minus mu k gt is here, that is the first equation. After t seconds the velocity reduces to this value. The velocity reduces to this value. Next after that, now because of this friction, angular velocity will increase. Angular velocity will increase. So that's why omega is equal to omega naught plus alpha t. Omega is equal to omega naught plus alpha t. So here omega naught means that omega naught can be taken as v naught by 2r. So it is v naught by 2r is there, and plus alpha t. Alpha that can be taken, it is alpha, and again after t seconds it is coming. Now first of all v is equal to v naught minus mu k gt, that is the first one, and here omega is equal to omega naught plus alpha t is here, and alpha also we can replace it, and because here you are given it is a sphere, so that's why alpha also we can find it in the next case, that is a torque is equal to I alpha. So now it is a torque is equal to I alpha is here, and torque is equal to, it is nothing but the F into R. So that's why F into R to be taken, F into R, and I is equal to, that I for the sphere is about that diametrical axis, it will be about that diametrical axis, it will be a 2 by 5 mr square. So it is a 2 by 5 mr square to be taken, and after that alpha is equal to A by R. A by R, alpha we can replace it, so that's why alpha is here like this. Next one, so now it is omega naught, and again the V naught by 2R is here, plus alpha t, and alpha torque is equal to I alpha, Fr is equal to 2 by 5 mr square. So now here we have to find out that alpha, and alpha is equal to F 5F by 2m is here. So 5F by 2mr is here. So this is alpha value. This is alpha value. So once again repeat, V is equal to U plus AT, that is the linear velocity is gradually decreasing and angular velocity is gradually increasing, and it is in a t seconds, its angular velocity becomes V naught by 2R, and alpha we are replacing, torque is equal to I alpha, and torque is equal to F into R, and it is 2 by 5 mr square alpha, and from that, that is alpha is equal to 5F, and again 2mr, that is coming here. So now here V naught by 2R, and thereafter in place of the alpha 5F is here, and 5F means already F is that is nothing but mu k mg. So that's why it is taken as the mu k mg is here, and thereafter it is 2mr, and t is here like this. Now next step it becomes V naught by 2R, V naught by 2R. Now here m will be cancelled, so it is 5 by 2, and it is mu kg by R is here, and t is also here like this. Now this is omega value. Omega value V naught by 2R plus 5 by 2 mu kg by R, and again the t. M will be cancelled like this. So next, this is the second equation. Now at the instant of a pure rolling, what we can take, it is V is equal to R omega. At instant of a pure rolling, V is equal to R omega. And V is equal to R omega means it is taken V naught minus mu k gt is equal to V naught minus mu k gt is equal to, that can be taken R of, and V naught by 2R plus 5 by 2, and mu k g by R into t is here. Here you are supposed to find out what is that value of t. After what time it gets at pure rolling, that you have to find it now. So V naught minus mu k gt. Now here R will be taken common, so that's why it is V naught by 2 and plus it is a 5 mu k g by 2, and again the t is here. 5 mu k g by 2 into t is here. Now we write it here. Now in this case 5 mu k g t, 5 mu k g t by 2 into t is equal to, and this is the plus mu k g t. So plus mu k g t is equal to, and what you are given, it is a 5 mu k g by 2 into t plus mu k g t is equal to V naught minus V naught by 2. So that's why it becomes V naught by 2 is here. That is becoming V naught by 2. And thereafter, now you have to take V naught minus V naught by 2. So it is 5 by 2 is here, and again the plus 1 is here, 3 by 2 by 2.5 plus 1, 3.5. So it is 7 by 2. 7 by 2 mu k gt is equal to V naught by 2. So from that t is equal to V naught by that is 7 mu k g. So this is the time after which, the body is getting pure pure rolling motion. The body is getting pure rolling motion. Its meaning is the velocity reduces from the 2r omega naught to 2, that reduces to r omega like this. So once again I tell you the concept of this problem. So initially when you are given this rolling body, it is not at all in pure rolling. Why? Because here omega naught is equal to V naught by 2R is given along with the problem. From that what you can see, that is V naught is equal to 2R omega naught. V naught is equal to 2R omega naught means V naught greater than R omega naught, that is cleared there. So that's why it is coming under that forward slipping case. So in that forward slipping case, that's why the contact points rub the road in a forward direction. So that's why frictional force will be in this direction. So when the frictional force is in this direction, then you can understand after some time that friction gradually reduces the linear velocity of this rolling sphere, and angular velocity because of the friction increases. And finally at the time of pure rolling it becomes V is equal to R omega. Now we have to find out after t seconds what is that velocity. V is equal to u plus at is there, and u is equal to V naught. U is equal to V naught is here, and again the A is nothing but the retardation because of the friction. So that's why this can be taken as the mu kg into t, and V naught minus mu kgt, that is the first equation. V naught minus mu kgt, that is the first equation. This is the velocity, linear velocity of that rolling sphere after t seconds. So V naught minus mu kgt. Next, after t seconds, what happens to the angular velocity? Here because of the friction, angular velocity will increase. So that's why this is to be positive only, and omega is equal to omega naught plus alpha t. And here omega naught is equal to, already you are given, that is initial angular velocity is the V naught by 2R, and alpha you have to find it separately. And for that we are taking that formula, torque is equal to I alpha, and torque is equal to F into R, and I is equal to, for the spherical body it is 2 by 5 mr square, and alpha is there. Alpha is equal to 5F by 2 mr, that is angular acceleration, that is alpha is equal to 5F by 2 mr. And thereafter when you are applying that 5F by 2 mr is here, and F also can be replaced by, it is the mu k mg. So 5 mu k mg by 2 mr, then you are getting that V naught by 2R plus 5 by 2 mu k gt by R, that is the second equation. And at the instant of a pure rolling, V is equal to R omega. V already after t seconds we have got this one, and t, that is after, that is t seconds, that angular velocity is becoming this one. So that's why V is equal to V naught minus mu k gt, and R is there, and omega is equal to this much, and here R is taken out and that will be cancelled, and it is becoming V naught by 2 plus 5 mu k g by 2 into t. So when you are taking these terms, 5 mu k g by 2 into t plus mu k gt is equal to V naught by 2. From that what you can obtain, that is t is equal to V naught by 7 mu k g. So V naught by 7 mu k g is there. Next one here, actually here you are supposed to find out what is the velocity at the instant of a pure rolling, and for that you have to apply this V naught by 7 mu k g in this first equation. So we are taking from 1. So here we are taking from 1. From 1 what we are taking, it is V is equal to V naught is there, and minus mu k, and g, in place of the t we are applying a V naught by 7 mu k g is here. So that mu k g will be cancelled, and V naught minus V naught by 7, V naught by 7 is here, and this becomes, it is a 6 by 7 V naught, that is answer. So it is a 6 by 7 V naught, that is a velocity of that spherical body when it is getting that pure rolling. It is a 6 by 7 V naught. Now we have completed that first problem. So now we are coming to this second problem. A man pushes a cylinder of a mass m1. So a man pushes a cylinder of a mass m1. So this is taken. So in this case, with the help of a plank of a mass m2 as shown. So that's why this is a plank. And in this case it is given m2. So m2 is here, and this is m1 is here. And thereafter there is no slipping at any contact. The horizontal component of the force applied by the man is F. So that's why the force applied is F is here, the force applied. And you are supposed to find out what is the acceleration of that plank and the center of mass of the cylinder. What is that acceleration of that plank and the center of mass of that cylinder? So that's why here you have to find out the accelerations of these two bodies, and as well as you have to find out the frictions at the point of contacts also, because that second bit is the magnitudes and the direction of frictional forces at contact points. You have to find out that frictions also. And for that we are taking the free body diagram of this plank as well as for that cylinder separately. So now we are taking this plank. So in this case, this plank is there, and again its mass is m2 is here, and thereafter its force is applied is the F, and here it is getting that acceleration a2, we think so, because the mass of that plank is the m2, so that's why a2 is here. And now here when it is moving like this, a normal direction of the frictional force will be opposing, so that's why we can take it is F2. So once again I repeat this problem. A man pushes a cylinder of a mass m1 like this. So if you consider this is a cylinder and he is pushing this cylinder like this with the help of a plank of a mass m2. Its meaning is he has not directly applied that force on that cylinder. He is applying the force only on that plank. Because of that friction in between this plank and the cylinder, that's why the cylinder is to roll forward. Now there is no slipping at any contact. The horizontal component of the force applied by the man is F. Now here you are supposed to find out the acceleration of the plank and the center of mass of the cylinder first. Acceleration of the plank means we are taking the free body diagram of this plank. So it is m2 is there, and again the a2, and applied force is the F, and F2 is here. Now the net force is equal to, that is the net force in this case m2 a2 is equal to, that it can be taken as a capital F minus F2 is that first equation. That is the net force is equal to m2 a2 is equal to capital F minus F2, that is the first equation. And when you are coming to this is for the cylinder here, for this cylinder here, now this is the it is placed on this horizontal plane like this, and its mass is m1. So here that mass is m2 and here the mass is m1, and here this friction, whatever that friction that is in between this plank and the cylinder, and that is retarding force for the plank. But the same friction is a driving force for the cylinder m1. It is a driving force for the cylinder m1. So that's why friction that can be taken in this direction. So F2 will be here like this. That is a driving force means because here there is no direct force applied on this cylinder. Only because of that friction in between the plank and the cylinder, this is to roll forward. So that's why F2 becomes the driving force for this cylinder and m1. And we take the general direction for this friction, that friction in between this, that is a cylinder and again this horizontal rough surface, it will be F1. Now we are taking this is F2, F1 are there, m1, it is getting that acceleration a1 is here. It is getting that acceleration a1. So in this case what we are taking, the corresponding equations are F2 plus F2 minus F1, and that is equal to F2 minus F1 is equal to m1 a1. And here we have to understand one point, and we don't know the direction of the friction is correct or not. Here we have given the general direction of the friction, which is opposite to that of the movement of the body. So that's why we have taken F1 is like this. If at all the direction of the friction, F1 direction is correct, if at all, then when you are finding that value of that F1, it becomes a positive. If it is positive, then you have to understand the direction of the friction is correct. So whatever the direction that you have assumed, it is correct. Next, suppose if at all it is negative, if at all that final answer is negative, then you have to understand the direction of the friction. Instead of this one, it should be like this only. It should be like this only. Then you have to change it later. So first of all, we don't know which is the correct direction for the F1. That's why we have to take the general direction of the friction only, which is opposing the movement of the cylinder. So that's why F1 should be like this.